All right, folks, we're back to the 5.5 notes. So excited. Okay, so just a reminder that these are not a base of e. The derivative for e to the x was just e to the x, which was really convenient. This is a little bit more involved. So what happens when we take the derivative of any exponential? Let's start with actually e to the x just so you can see how it works. The derivative is e to the x times the ln of the base. Okay, but the ln of e is 1, so that's why that cancels. For this, I don't know what the ln of a is, so I just have to write it like that. So the only difference is if you have u as an exponent, something other than x, it's a to the u times the ln of u times u prime. So it involves like a little bit more because you have to do the chain rule. Same thing with if I take the derivative of ln of x, just a reminder that it's 1 over x times the ln of e, because that was its base, but again, that canceled. So if I had ln of x, that was the derivative. This involves a little bit more because it's a log, so I have to do 1 over x, or whatever this is, times 1 over the ln of the base. So we tend to write this as 1 over x ln of a in one big fraction. Okay, so it's really similar to what you see for the derivative of the exponential, except you have 1 over x times 1 over ln of a, okay? Or 1 over x ln of a. Same thing here, it'd be 1 over u ln of u times u prime. Because again, you have to take the derivative of u. All right, so let's try that. So in this case, you don't actually have to do that much more math with these because it's just 5 to the x is your derivative for y prime. Let's actually write y prime so we know what we're doing. Times the ln of 5. We don't know what the ln of 5 is, so you can actually just leave that. You don't have to simplify it anymore. Okay, the next one, again, super similar. So y prime is 5 to the 3x minus 5 times the ln of the base, which is 5, times, this time the problem is that our exponent isn't just an x, so I have to multiply by the derivative of the exponent. So it's times 3. Now, there's not a whole lot you can actually do here, so I just tend to rewrite this a little bit to make it cleaner and say it's 3 ln of 5 times, be careful you can't multiply the bases because they have different things going on here, and only the 5 is being raised to the 3x minus 5. Okay. The third one, you have to use the quotient rule. So try it. Refresh your memory a little bit. When you're done, I'll have it for you. All right, folks, your answer's on the bottom. Technically, you could factor out the 3 to the 2t if you want to, because it's in both parts, but it's not going to help you here because it would just be 2t ln 3 minus 1 in parentheses, which doesn't simplify. So I tend to not factor those common terms out unless you can do something after you do it. So it's not going to be beneficial to factor it. But remember, it's low d high. The derivative of the high is all this, minus high d low, which is really 1, all over low squared. And I just cleaned it up a little bit. Sorry, that was an ad about bacon. Okay, next up, we are looking at log derivatives. So we're going to try a few together, then you'll do some like we're used to doing. All right, so just a reminder that for this, if you need it, those are parentheses. So your derivative of a log is 1 over the value, so that's the sine of x, times, still underneath parentheses, the ln of the base, times the derivative of, we'll pretend like this is our u, right? So u prime, so that's going to be cosine of x. This you can actually clean up a little bit more because if I look at my numerator, this is my numerator, this whole thing is my denominator, but there's a sine of x in my denominator. And what is cosine over sine? cotangent, yes. And again, just leave the ln of 10, even though it looks ugly, it's fine. All right, next up, product rule and a little chain. Ugh, gross. I personally would probably simplify or rewrite this first. Also, this is y prime, sorry. So I would rewrite this as x to the 3/2 times log base 2 of x plus 1 to the 1/2. Just because when you take the derivative of it later, it'll be easier to calculate. Okay, so product rule. First times the derivative of the second, which is a giant annoyance. So if you 1 over x plus 1 to the 1/2 ln of 2, right? Because you have to do times the log of the base. But then you have to multiply by the derivative of this, which you have to use chain rule for, so it gets a little gross. 1/2 x plus 1 to the negative 1/2 times the derivative of the inside, but the derivative of the inside is just 1. So that was convenient. So that was first times the derivative of the second, plus the second, so log base 2 of x plus 1 to the 1/2 times, sorry, that's supposed to be times, the derivative of the first, so 3/2 x to the 1/2, okay? So I'm just going to clean it up again a little bit. So your y prime, if you want to make it look pretty, is x to the 3/2 over, the nice thing is that these actually simplify to, it's like saying negative 1/2 minus 1/2, so it's like negative 1. So if you bring it down to the bottom, I'm going to rewrite this as 2 ln of 2, because I'm just like moving things together. But this is really like x plus 1. If you didn't know how I got that again, x plus 1 to the 1/2 on the bottom, and combining the numerator that has a negative exponent, you could either subtract the exponents or bring this down first and add the exponents because they have the same base. 1/2 and 1/2 give you 1. Plus, this is a giant problem, 3/2 log base 2 of, I'm going to rewrite the radical just because I like it better. It looks prettier to my eyes. And then times the square root of x. You can't combine the radicals because this is the log base 2 of this whole thing. And then it's times radical x. So if you'd rather put the radical x here, you can. Whatever's easier for you. You could put parentheses around it to make your life easier too. We're done with that one. Okay. The next two are actually going to be easier because it's variables and constants together. This is kind of like that quiz we did where I gave you a bonus question that said what was the derivative of pi. It's 0. So the derivative of e to any number. This is a number. So the derivative is 0. Ah, fun. Okay, the derivative of this one's a little bit more complicated, but again, this is just a number. So bringing back just a reminder of what the derivative of e to the x is. It's e to the 3x squared plus log base 4 of 7 times the derivative of the exponent, which is just 6x, because the derivative of this part is 0. So this is sufficient, unless you want to put the 6x in front. That works too. Okay, same idea. Think about this as like x to 2.8, because that's really what e is. So think about what we'd normally do. Bring it in front, subtract 1. So, excuse me, this is the same thing as e to the, or e times x to the e minus 1. That's your derivative. All right, we are almost done. So we did 7, 8, 9, 10, 11, 12. We have one more slide after this page. So, logarithmic differentiation, really, really important here. It has to be used when the base and the exponent are a variable, okay? Most of the time I'll preface this kind of problem with this anyway, but this is why you have to do it. It's a little different than what we're used to. So you actually want to, before you take the derivative, take the ln of both sides. Okay? Because the reason we do this, it's going to make your life easier. This can go in front. So you haven't taken the derivative yet, just be careful. Okay? And then from there, yeah, you have to use product rule, but it does make your life easier because then the derivative of ln of y is just 1 over y times the derivative of y, 2y dx. This is not new to us, but then this one you have to use product rule. So first times the derivative of the second plus the second times the derivative of the first, which is just 1, okay? So your last step is to move this, well, really second to last step is to move that y back over. So multiply both sides by y. I'm going to rewrite it for you first before we do anything else. I might even just distribute this because it's fun and it looks prettier because the x's cancel. Okay, your last step is going to be to sub back in what y is. Whoop, like we're used to doing, but some people forget to do this part. So it's really x to the x minus 1 times 1 minus this. That's it. And there's not a whole lot you can do. I mean, technically you could distribute the x to the x minus 1 if you want to, but the only thing it can actually combine with besides the 1 is this. So don't. Excuse me. It's sufficient for your answer. Sorry, the baby is deciding to keep me up at night, so I guess I should get used to that. Anywho, same thing here. So try the next one on your own. I'll have the answer up in a sec. All right, guys, hopefully you got what I got. Just a reminder that, first of all, this is the answer. Just a reminder that when you get to this point, when you bring down that exponent, which hopefully you did before you took the derivative, 1 over x is the same as x to the negative 1, so the derivative is actually that. And then you want to turn it back into, like, I cleaned it up a little bit from here to here. And then you have to substitute y back in. Okay? All right, last one, folks, and then we'll go on to integration tomorrow. Okay, equation of the tangent line. 8 millionth time we've done this, except now we're doing it with e and ln and all that stuff. Fun things. So just a reminder that if you have a base that has a variable and you have an exponent that has a variable, you want to use logarithmic differentiation to find the derivative first. Because remember, you take the derivative to find the slope and plug in the x value. So we're going to start here. And again, the whole point of this is so your exponent goes whoop right down in front. It's one of those nice rules about logs. That's a sine of x, by the way, not just sine. And now you have to use product rule, but take the derivative of both sides. So this turns into 1 over y dy dx equals, and then product rule. So first times the derivative of the second. Don't forget to multiply by the derivative of sine, which is cosine, plus the second times the derivative of the first. Okay, make sure you put parentheses around things like that if you get confused. Move that y over. Okay, and then sub back in. So let's do 2x, cosine over sine is really cotangent, plus 2 ln sine of x. Okay, and then you can just sub back in y. And I forgot that where you have to still find the slope, so hopefully you have more room. So sine of x to the 2x times 2x cotangent of x plus 2 ln sine of x. So sub in pi over 2 for x. Tell me what you get, and hopefully you get the same thing as me. You can plug it right into your calculator if you want to. So you should get, weirdly enough, 0 as your slope when you plug it in. So if you plug in pi over 2 for all the x's, the cotangent of pi over 2 is 0 because it's x over y. So this whole thing becomes 0. This part is 1. That should be sine of x, aka pi over 2. So you end up with 0 times the original, which ends up being, because this is 0 as well, just so you know, like sine of pi over 2 is 1. But then if you do the ln of 1, that's 0. Now, if you got an error because you didn't know how to plug in cotangent into your graphing calculator, it's helpful to either leave it in terms of sine and cosine first and then plug it into your calc that way, or think about it, just thinking about your unit circle. If you try to plug it in as 1 over tangent, you're going to get an error. So anyway, your slope ends up being 0. So your equation, if you were to plug in 0 for your slope, ends up being y minus 1 equals 0 times x minus pi over 2. This cancels, right? So you end up with y equals 1 as your tangent line. And if you were to graph it, you'll see that as well, that the tangent there is going to be a horizontal line. All right, folks, enjoy the rest of your day. Part 3 will be coming at you tomorrow.